The purpose of this video is to explain how to calculate the Simpson's index, which is a way of measuring biodiversity. The formula for the Simpson's index is the summation of all species individuals over the total of species individuals. So this represents sum, which is another word for add. This little n represents the number of species individuals. This number represents the total number of individuals. And this is essentially a probability. So this is based on statistics. Now, for each species, we have a number of individuals, and that is what our little n represents. So for the pigeon, it's 96. For the robin, it's 1. For the starling, it's 2. For the purple grackle, 1. So on and so forth. So simply what we do, since it's already sort of arranged in a table, is if you see that the top of our fraction right here, that's what this is right there. So that's going to go in the top of our denominator. Excuse me, it's going to be the numerator, or the top of our fraction. And then we will simply plug in this number n to get what goes on the bottom of our fraction. There, that should make it a lot easier to see since I focused. So now we simply 96 minus 1 is 95, and then this is going to be 96 times 95, which I plug into the calculator, is 9,120. 1 minus 1 is 0, 2 minus 1 is 1, and then when we multiply, we get 1 times 0, which is of course 0. We have 2 times 1, which is of course 2, and then these are obviously 0. And this is where the summation part comes in, so we simply add all of these up, and of course the number is 9,122. So now we know that 9,122 is what goes in the top of our diversity index fraction. To calculate the total number of organisms, we simply add them all up. So we have 97, 98, 99, 100, and it's 101. And so what goes in the bottom is n times n minus 1. And so our n is 101 times 100, which equals 10,100. And then we simply divide it. And this is going to give us 0.903. And then real quick, I want to draw your attention down here. The Simpson scale ranges from 0 to 1, with 1 representing the lowest biodiversity and 0 representing infinite biodiversity. So if we look at the individuals for campus B, we're going to notice that whereas for campus A, we had 96, 1, 2, 1, 1. If you look at campus B, you see that you have 20, 20, 20, 20, 20. So for this number, we're going to expect a number that's lower because it's more diverse, right? So this is almost 1, and we're going to expect a number much lower. So let's go ahead and calculate this together. The thing about this one is it's very easy because it's the same all the way down. You have 20 minus 1 is 19. 20 times 19 equals 380. And so of course it's the same all the way down. And then our total is 1900. Our total number of individuals is 100. So if we have our equation, we figured out the top, which is 1900. The bottom is going to be 100 times 99. We simply divide these two, and we get a number that is much closer to 0. And so we can say that this is more diverse. I hope that helps you understand how to calculate the Simpson index.